Hello everyone! Today we are going to talk about the product that a lot of us use in our daily lives. This product is the corrective lenses. Then we will dive into its history and composition and talk a little bit more about one of its major components.
About 168.5 million Americans use some form of corrective devices, such as eyeglasses or contact lenses.
In 1508, Leonardo da Vinci proposed that by submerging one's head in a bowl of water could alter their vision. This was super impractical because one cannot breathe underwater.
In 1636, René Descartes tried improving this idea by instead putting a glass tube filled with liquid in direct contact with the cornea. He gave contact lenses their name, but still, this was a terrible idea.
In 1801, Thomas Young reduced the size of the glass tube to 1/4 of an inch. He used wax to stick the water-filled lenses to his eyeballs, which failed.
In 1845, Sir John Herschel finally comes to the rescue and comes up with the idea that these contact lenses could correct the refraction errors that cause nearsightedness, farsightedness, and astigmatism.
By the early 1880s, Dr. Fick invents the first contact lenses with refractive power for visual improvement. Oh, and people could actually blink with these on.
Dr. Dallos made molds from living eyes to improve the fit to the human eye.
In 1950, George Butterfield came up with curved rather than flat corneal lenses. Finally, a genius in the mix.
In 1960, Bosch and Lomb refined the technique of casting hydrogel, which produced consistent lens surfaces. These lenses were then mass-produced.
In 1998, Ciba Vision introduced silicone hydrogel contact lenses that are known for their comfort and high oxygen permeability.
Today's best contact lenses are breathable, durable, and comfortable.
Enough about the history. Let's get into how these contact lenses work.
Contact lenses are small prescription lenses that are worn in contact with the eye. They are designed to correct refractive errors and focus light.
Lenses stick to your tear fluid on your eye, which is why they move naturally with your eyes. Contact lenses are used to correct problems associated with the refraction of light by the eye.
There are two main types of contact lenses: hard, made of gas-permeable polymers, and soft, made of water-loving polymers. Contact lenses are also designed for different refractive errors, like nearsightedness, astigmatism, farsightedness, and more.
For nearsightedness, the light ray from an object is focused in front, not on the retina. This allows people to see nearby objects clearly. This lens is concave with a thinner center and thicker edges to deviate the light gained from distant objects.
The lens of the eye has a decreased potential to refract light emitted by an object, making the focus beyond the retina. The lens is convex to lower the focal length of light, and the converged light is deviated by the lens of the eyes.
For astigmatism, a specialized lens called the toric contact lens corrects the bend in the cornea of the eyes. This lens has different focal lengths and optical power formed at a 90-degree angle. When the light of an object passes at these right angles, multiple focal points attained on the retina are fixed.
Other lenses are designed for the purpose of cosmetics, like prosthetic or colored lenses. Now that we know how contacts work, what are these contact lenses composed of to give them their durability and comfort? The most durable, breathable, and comfortable contact lenses used today are the soft silicone hydrogel contact lenses.
It combines water-absorbing plastic of soft lenses with silicone. They are more porous than hydrogel lenses and allow for more oxygen to transmit through the contact lens into the eye.
Elements and components that make up the silicone hydrogel contact lenses are silicon, fluorine, oxygen, hydrogen, hydrogel, hydrogen peroxide, hydroxyethyl, methacrylate, and flexible plastics.
Monomers commonly used in hydrogel contact lens material include N-vinyl pyrrolidone, methacrylic acid, and poly-2-hydroxyethyl methacrylate. These components allow the lens material to absorb and bind water.
In silicone hydrogel materials, silicone rubber is combined with these monomers. The silicone component provides high oxygen permeability. The hydrogel component facilitates fluid permeation that enables the lens to move on the eye.
To render the surfaces of these lenses hydrophilic, gas plasma surfacing was used to modify the lenses, without impeding the flow of oxygen and fluid. The surfaces were treated in a gas plasma reactive chamber, as you can see, which converted the silicon components on the surfaces into hydrophilic silicate compounds. This results in the glassy silicate islands and the hydrophilicity of these area ridges over the underlying hydrophobic biofilcon material.
Silicon is an important element found in these lenses. It is the second most abundant element in the Earth's crust. Silicon can be found in sand, clay, glass, and computers.
Silicon was discovered by a Swedish chemist, Jöns Jacob Berzelius, in 1824 by heating chips of potassium in a silica container and washing away byproducts. It is a metalloid that is produced by heating sand or silicon dioxide with carbon to temperatures approaching 2,200 degrees Celsius.
Silicon commonly takes the form of sand, but it can also exist as quartz, rock, crystal, jasper, opal, flint, and more. Silicon can be used differently in these various forms, and because of this, it has a commercial and economic impact.
Silica gel, a colloidal form of silicon dioxide, absorbs moisture easily and is used as a desiccant. Silicon carbide is nearly as hard as a diamond and can be used as an abrasive for ceramics or leather shoes, for example.
Sodium silicate, also known as water glass, is used in production of soaps and adhesives. Silicon tetrachloride is used to create smoke screens.
Silicon wafers are used to make solar cells and solar panels, and then silicon oil is used as a lubricant added to lotions, makeup, and sunscreens. Silicon dioxide is used, however, to strengthen the cement.
Silicon is used as a semiconductor in devices in the computer. Silica gel polymer is used for DNA extraction.
Silicone adhesives and coatings are used in buildings and transportation. Silicon is used to make rain gear waterproof.
Other facts about silicon include an atomic mass of 28.1 grams per mole, a melting point of 1,410 degrees Celsius, and a boiling point of 3,265 degrees Celsius. Silicon can be dangerous if inhaled too much, causing irritation to the lungs and the eyes. Lung cancer, bronchitis, and emphysema is associated with exposure to crystalline silica. Finally, to visualize how silicon actually looks like under the microscope, here is a picture that is taken by a scanning electron microscope of the silicon. We hope that you found this video helpful and interesting. Thank you for watching.